All right. Are we live? I think we are live. Right. All right. Let's do this. This. Beautiful. All right, we're in. Hello, everyone. Thanks for joining us. If you're checking us out, if you're all the way back to the start for some reason, because nobody's here right now. But yeah, let's get started. What do you think? All right. Let's do it. Oh, we didn't connect. Let's see if we can connect the Discord to Nightbot. Okay, let's see if we can get our Nightbot set up. All right, we're in. Get the integration going. Okay. Um, okay. We're refreshing the old. Password. Very quickly here. Very quickly now. Okay, that should work. So then that should work. is Nightbot. Let's see. I see. Okay. All right, cool. Okay, and we're live. And Nightbot's in. All we can ask in this world, right? Yeah. Okay. Nice. All right. Sorry about that. Let's do it. Oh. Thank you very much, Wim. Vom today. Yes, something I've always said. Vom today, you know? All right. All right. Let's get started. Find the equation of a circle with the center 0, 0, passing through 2, -5. Okay. So we have our circle. Yeah. The center of the circle is 0, 0. 0, 0 is the origin. Okay, so let's put the center there. Yeah. Okay, and then it says it passes through the point 2, -5. So, you know, in this world, without knowing anything about the circle, we could probably guess where 2, -5 might be and draw it on here. Okay, so 2, -5, so that's the x, comma, the y. And where are we going to put that? So that's x is +2 and y is -5. So maybe something like, I don't know, like it. There to -5, right? It's not horrible. Not horrible. Okay. So it says find the equation of the circle with the center 0, 0 passing through. So now we have to find the equation of that purple line there. Okay. So let's call that f of x. Okay. Actually, I want to put, maybe take the chat out. Yeah, I think that's helpful. So let's put u. want you over there. And then I want you here. And then I want you there. And then I want you there. Yeah? All right, we're in. Boom. Divine Machi. All right. Okay, so back to this. We're going to call this f of x, right? This is going to be our equation. And the general equation of a simple circle looks like this. Okay? Where the r there is usually just a constant. Okay, the whole thing. So for example, if that thing is, the x and the y in equations that you've seen, something like this, they stick around, right? But then everything else is numbers. So the r squared there is going to become a number. If it was 25, that tells you that r squared is 25, so r must be 5. Yeah? So, okay. And what we're saying is that every point, every xy point will work in this equation. So that is the general form. So maybe I just don't erase all that stuff. And I just leave that. Okay. So let's just say the general circle at 0, 0. So when I say at 0, 0, that means the center is there, right? Okay. And what do they tell us? They tell us a point. They tell us an xy point, right? So this one is centered at 0, 0, so we don't really have to look at the one that's not centered at 0, 0. We can after this. If anyone shows up, please. Anyone out there besides Winnie Mazoozle? Bum today. Anyway, let's just say that x squared plus y squared is r squared. It's our job to figure out what the r is here using our x and y, right? We said that we have an x and y here. So we have a 2 squared plus -5 squared is equal to r squared. So let's do some solving here. Plus 25, so that's 29, is equal to r squared. So r is the square root of 29. Yeah? Oh gosh, I'm blocking it. I'm blocking it, mate. There we go. Boom. Okay. You're blocking it, mate. Ambrosia. Stop. No. Come here. Come here. Come here. Come here. Up. Hey. Come on up. The dogs. Dog doesn't want to cooperate. Okay, so back to it. So r is the square root of 29, right? Which doesn't really matter because r squared is 29. So we've just figured out the equation because all we needed was the r squared, right? So our answer is x squared plus y squared is equal to 29, baby. Boom. Okay. That's our answer. Right. Okay. So we're good. Let me just maybe just kind of make this look a little nicer. I don't need this big ugly thing here. Just do this, and then even just get rid of this and do this. Okay, beautiful. So that's our answer there. Okay, Next question. Anyone out there has got a question? I'll answer it for you. If you don't, then I've got my own. All right. Back up. All right, we've got a pair of questions here. This will get us warmed up. This will get us in the mood here. Let's do it. Come on, mate. Where are you at? All right, let's go. So we have to solve the following system of equations. Solve the system of equations. What does it mean to solve the system of equations? It means give the value of all the variables. Okay, so that's what it means to solve these equations. Yeah. Okay, let's keep doing it. So what we're gonna do, we can do this a few ways. Actually, maybe the first one I'll do one way, the second one I'll do the other. Okay? You want to come here? Come on. Come on, you needy poo. You needy poo. Oh, there she is. Okay. So, what are we doing? We're solving the system of equations. So, we are going to have to, you know, if this was something simpler, if this was like x plus y is equal to 7 and y is equal to 2, well then I would plug that y is equal to 2. If y is 2, then that is 2, and you'll never know the difference, right? And then it just looks like this, and that's nice and easy to solve, right? So that's my goal, and really that's just substitution, right? That's just eliminating variables. So let's do it. So it looks like my sort of instinct here is maybe to get rid of y using those two. Yeah? So let's do it. Let's get rid of y using those two there. Okay? Actually, let's just start with x, okay? So let's get rid of x using those two, okay? So x plus 2y plus 2z is equal to 6, right? And 3x plus 2y plus z is equal to 9. Okay. In order to sort of get rid of them, what we're going to do is we're going to subtract these two equations, okay? So what I actually want is I want a 3 out front there. But in order to do that, I actually have to do that to the entire both side, right? So basically the entire sort of line, right? So that's what we're going to do, okay? So let's just sort of, you know, turn this into 3x plus 6y plus 6z equals 18. And now that is something that I can subtract with this pretty directly, right? So I'm just going to subtract each of these. So the whole point is that I get 0 there. Here I get 4y. Here I get 5z. And don't even talk to me, Americans. And here I get 9. Yeah, so now what we've done is we've eliminated x. This is now an equation with y and z, right? So if we can come up with another equation with y and z, then we have 2 equations, 2 unknowns, and now we've gone from 3 equations, 3 unknowns to 2 equations, 2 unknowns. And then we'll do that. Again, we'll go from 2 equations, 2 unknowns to 1 equation, 1 unknown. Yeah? Okay, let's do it. So that's a y and z, right? So that's good. Let's do, so how can I represent this? This is maybe just, this is 1 and this is 2, right? Okay, so now I'm going to use 1 and 3, and I'm going to try to sort of do the same thing, okay? So I have x plus 2y plus 2z equals 6, and I'm basically going to need to multiply that line by something, because this line has a 2x plus 5y plus 5z, and see how the y things and the z things don't matter right now, because all we're concerning ourselves with are the x, and we'll deal with the y and the z later. Yeah. Okay, so then we get 14, and we're going to need to multiply this by 2 so that those two things match up. Okay, but we have to multiply everything by 2. So we actually get something that looks like this. 2x plus 4y plus 4z is equal to 12. And we can bring this over, because we're going to use that actually itself, and we can subtract the 2. So when we subtract the 2, what do we get? We get 0. That was the whole point. And then we get negative y. So I'm just going to say minus y, or negative y. And negative... Go. I'm actually going to rearrange this subtraction. Okay, so I'm actually going to do 3 above 1. And the reason is because these values are all higher. So when I do the subtraction, instead of getting a bunch of negatives, I want to get a bunch of positives. And that's fine, right? Because the whole point is, as long as I get 0 there, then I'm good. So now this is positive y, right? And that's what's nice. So let me just line these up now. So this makes sense there now. This is the subtraction that we're doing. There we go. Okay. So there we go. So now I get 1y when I subtract these two here, right? And then I get 1z, and then I get 2. So now this is 2 equations, 2 unknowns, right? So we've done it. We've done it. We've gotten a heck of a lot closer. So let's move over here. Let's move this over here. Bada boom, bada bang. Okay. Right. The delay, I think, is better today. It's good. Okay. Boom. And a boom. Right. Okay. So now our job is to sort of eliminate another variable. So I sort of see a good opportunity here, just like we used the fact that that was just a simple 1x, means we can multiply it by something simple, right? We're going to do the same sort of thing here. I see a 1y and a 1z, so I'm going to multiply, let's eliminate y, yeah? So let's multiply this by 4 and this by 4. So let me actually just do this. So we're just going to multiply both sides by 4, and what do we get? We get 4y plus 4z is equal to 8. And this one says 4y plus 5z is equal to 9. So we should be able to sort of tell what z is, maybe even just by looking at it, but if not, let's do the subtraction. We're trying to eliminate y. That's good. That's why we wanted to do it. So we're going to subtract this whole side here, right? So that's maybe kind of like not something that I'm showing with the negative there. So let me do this. Okay, so then it's 5 minus 4, right? So it's 1z, and we just write that as z. And it's equal to 9 minus 8, which is 1. So z is 1. And now we can just go backwards, right? Because remember this equation, if z is 1, then we can replace this z with a 1, right? And then this looks like the equation. So let's just say sub in z equals 1. Then this becomes y plus 1 equals 2. And so y is equal to 1. Right? And now we can go back and maybe go back to this first one here. That first equation there. Right? So we're going to, let's just maybe say, let's maybe move this over here. I'll do this. Bada boom, bada bang. Bam. Boomst. Bamst. Boomst. Bamst. Okay. Let's move these around a bit. Okay, so now this went into that, and this went into that. And we got our z equals 1, right? And we can now use that. We can now sub back in to solve for x and y. Okay? So let's maybe just do this. Do that. Boom. How's that? So y plus 1 is equal to 2. So y is equal to 1. And then x plus 2, 1 plus 2, 1 is equal to 6. And so x is equal to 2. So that's our solution. X is equal to 2. Y is equal to 1. Z is equal to 1. Boom. And we should be able to check this by plugging it into another one. So let's maybe just try plugging it in here. So 2 times 2 plus 5 times 1 plus 5 times 1 is 4 plus 10 is 14. We're good. Right? So that was a check. Check the solution. Right? Okay, beautiful. And so that's our solution there. Okay? So you see how like some of this becomes about organization more than anything. Okay. Now, let's see the kind of fast way. You'll notice that what we were doing was we were sort of operating, like if we kind of look at the green here, and maybe that's a better way to represent these, right? Because that was a subtraction. That there was a subtraction, and then that there was a subtraction. Right? So the operations that we did, at first we sort of did a multiplication by 3, right? So let's just say like times 3. And then we did a subtraction, right? So subtract rows, right? So that maybe this, say this is like 1 minus 2, right? Write this in. Oh gosh, let's go brain, let's go. 1 minus 2 brain. Come on brain. All right. So 1 minus 2, right? And then what was this one here? This was a multiplication by 2, right? Of a certain row, multiplication by 2. And this was a subtraction of rows. So it looks like we're sort of doing simple operations with entire rows. And that's actually the simplest way to sort of understand the next method. And so this is, what was this? This was 3 minus 1. Nice. I didn't mess it up. Okay, so that's the best way to understand this method. I'm just going to kind of show this and see if we can maybe understand it after. Okay, so we're going to put a little line here. We're just going to take the numbers that we have here, and I'm going to be careful that they are lined up. So they're all going to be, for me, x, y, z. Okay, and this is on the sort of other side of the equal sign. Okay, and so we have 7 plus 5 minus 3, and all I care about are the signs, because the x and the y and the z are always there. Okay, so that's kind of what I'm doing, is I'm ignoring the things that are always there. And then we have 3 minus 5 and plus 2 and 5 plus 3 minus 7. Okay, so using the same method here, we should sort of see the same operations that I'm about to do. Okay, so if you want to, you can try this question using this method here. Okay, which is just called substitution elimination. Okay, so instead we're going to kind of tell them what we're doing here, but let's do row. Well, I see an opportunity maybe here. Okay, so I want to add row, so I'm going to add row 2 to this row here. Okay, so in that way I'm going to write, instead of what I have here, I'm going to replace it with this. Okay, so let's do that. The whole bottom half stays the same. The whole bottom 2 rows stay the same. So this is the nice part of cut and paste. Okay, but now we have to replace these with what was there plus what is under it. So this is now 10. This is now 0. That's why we did it. And this is now what? -1. And this is now 8. Okay. Now the reason we're doing that is because getting 0 is the same as eliminating one of these variables, right? Like if the variable there, or if the number there was 0, then there would have been no actual y there, right? So that's kind of what we're doing, is we're eliminating the variables. That's the whole goal, is to get these zeros, okay? And we actually want it to look like this. With some numbers here. Okay, because then we can say 1x, 1y, and 1z, and what each of those things in that order mean. Yeah? Ah, thank you. I appreciate your contributions. Vor red. Yes. Thank you. I've always said it. All right. Don't get those. Vor red. For red. Okay. So anyway, let's get back to it. What do we have here? So let's see if we can manipulate this a little bit more. Let's see if we can try to get rid of that row and keep just this sort of 10 around, or any number there. Okay. So I'm looking to the second one here. Okay, so what I'm going to do is I'm going to multiply this row by 2. Okay. And I'm going to add it to row 2 again. Okay. So again, I'm just going to keep maybe just say this. Okay. And so what do we get? Well, 2 times 10 plus 3 is 23. 2 times 0 plus 2 plus -5 is -5. So see the problem here when we try to eliminate multiple here? What we need is another one with a 0 in the middle. So let's do that on this one, because that one needs a 0 in the middle. Remember, it needs to look like this. So let's just say this is my goal. Right? And so we want to, let's do the same thing on the bottom first before we do this, because we don't want that -5 to show up, okay? So let's actually, sorry, let's just erase this. Let's not do this. Let's just keep what we have up top, 10, 0, -1, and 8. And let's play with the bottom two somehow and get rid of the middle on the bottom one. Okay, so I see that I'm going to have to multiply that bottom one by 5. So R3 times 5 plus 3 times R2. Okay, so that's ugly, but it's not impossible. Okay, so let's do it. So 5 times R3 is 25. And then plus 3 times R2, so that's 9. So 25 plus 9 is 36. No, 25 plus 9 is 34. Okay, so 34. The whole goal here was that that was 0, so I hope that becomes 0. 5 times -3 is, 5 times 3 is 15, plus 3 times -5 is -15. So we add them together, we get 0. And then the third one, so 5 times -7, so that's -35. And then plus 3 times that one. So instead of the 2 there, there's 6. So I'm actually adding 6 to this. But because it's negative, it goes down. So it's actually -29. It goes down by 6. Or, you know, the number goes down by 6. Okay? Whoa! Hey, take a zoom out, okay? Now's a moment. Take a second. What are you grateful for today? All right. Okay. So, okay, so now we can do it, right? Now we can play with these, you know, these two on the top and the bottom without the middles getting screwed up because they're both 0, right? Okay. So now let's play with these two. Okay, so -29 I think is prime. 29 is. So let's multiply the top by 29, right? Or -29. -29 times the first one plus the second one, or the third one there, sorry. Yeah? Okay. So -29 times that one plus that one. Let's see what happens. So -29 times 10 is -290 plus 34 is -256. Right? Yeah. Okay, and then 0, that was the whole point, that it didn't matter. And then 0, that was why we did it. Right? So we got +29 here, and then we add that to -29, we get 0. And now we just have to do it to the other side. So we figured out what this is, but I mean, it's going to be ugly, but we can divide by 256 soon. Okay. So -29 times 8. Okay. -29 times 8 is -232. And then we have to add that to this side, which is 0. Okay, so that's fine. Get -232. So These numbers looking nice or not so nice? Something happen. Maybe not. Let's keep at it. So, okay, so now I'm just going to divide this row by negative 256, because then we get to the 1 that we need there, right? So negative 234 divided by 6. Okay. So we get 1, 0, 0. And then this is actually, I think this is a, is that an 18th? Okay, so over 32, it's 29 over 32. Yeah. Yeah. Okay, so 29 over 32, and then we can use that. Oh, okay. So then we can use that moving forward. So 3, negative 5, 2, negative 8, and then 34, 0, negative 29, and 0. Well, we know what one of these is, so we should know what 34 of them is, right? So 34 times 29 divided by 32. Is 986 over 32. Okay, the reason I'm slowing down and kind of getting skeptical is because these numbers don't look so nice. I'm thinking maybe I screwed up my math somewhere. So let me just double check here. So we add these two together, we get 0, 0, negative 1, we get 8, yes. And then we do 3 times R3. 5 times R3, so 25. Yeah. Oh yes, this is where the ugly one came from, right? 7 there. Go on the other side. Wait, is that right? 0 on the other side? No, it shouldn't be 0. Should be so negative 24. Right? Negative 24. Okay. Yeah. Okay. Okay, I mean, let's just kind of keep cruising here. So let's just get this one over with. We're doing some matrices here. This can be tedious. Okay. So we did that. Now, what I want to do is I'm going to do well, I'm going to do 34 times R1, sorry, negative 34 times R1 plus R3. And that should eliminate our should eliminate our first row there. And then this will be a disaster, but that's fine. So, oh no, so that just goes there, and then negative 34 times 32 over 29 plus negative 24, so minus 24. Is that right? Yeah. Okay. So 34 over 32, that's going to be 17 over 16, 29. So what is 24 times 16? So negative that plus 384. Okay. So 17 times 29 plus 384 is negative 877 over 16. Negative 877 over 16, but I think that that is divisible by 29. So no, it's not. That's okay though. Okay. Okay, yeah, so that's just an aside. And then we now can divide that row by negative 29. And we're getting pretty close here. So let me just do this. Boom, boom. Boom. This is just going to be 1. And this is going to be positive 16 times 29 is 464. And now now we can use that middle row there. So I'm going to take negative 3R1 and negative 2R3 and add it to R2. Okay, so this is going to combine all 3 of them. Okay. So in the first circumstance, negative 3 times 1 is negative 3. And this one's 0, so it doesn't come in. But then plus R2. So I actually get 0 there. Right? This one is already 1, 1, 0, 29 over 32. So we get 0 there. Okay? The middle one, it doesn't change that negative 5. That negative 5 doesn't change because we have zeros above and below. Right? Okay. You can still see this, right? Well, okay. So where this negative 2 comes in is into our third line there. So we do negative 2 times R3. So there we get negative 2, and we add that to 2. So we should get 0. And now this is where the nasty math comes in. So negative 3 times 29 over 32 minus 2 times 877 over 464 plus or minus again 8. Okay, so 32 okay, so 3 times 29, so we get negative 87 over 32. Okay, so then we can make this minus 877 over 232, and then minus 8. So let's just make 8 times 232. So minus 1856 over 232. Okay, and we're getting there. So let's just make that first one. So 232 divided by 32 is 7.5. So then 7.25. So that times 87. Oh god. Okay, so we get 630.75. Okay, so then we're just gonna have to multiply things by 4. That's fine. 232 minus 877 minus 1856. And those are both over 232 as well. We're getting there. Okay. And so we bring those together. Oh my goodness. And then we multiply that by 4, I'm assuming. 3, 6, 3, 5 over 232. And then that times 4. 1, 3, 4, 5, 5 over 232 times 4, 928. You know it. This classic ratio that we've all come to know and love, and we're still not even done. Is it positive or is it negative? It's negative. Don't forget it. It's worth a zoom out and a check. It's negative. Let's just double check that some of these didn't lose their negativity. No, that one should lose its negativity. Should become positive. Good. And that one is both negative, so they should both be positive. Beautiful. Okay, so then we're almost done. We just have to divide this by 5 now. We've got our identity, all right? Our identity. Okay, so then we are going to take this thing and divide the middle row by 5. Not bad at all. Okay. So we're going to do 1 over 5 times R2. Boom, baby. So 1 over negative 5, so that we end up getting rid of the negative, so that this becomes just positive 1. And now this should become positive and then just be divided by 4, 6, 4, 0. Right? Or that's actually divisible by 5. So let's do that actually instead. 928. 1, 3, 4, 5, 5 divided by 5. 2, 6, 9, 1 divided by 928. You know it. So that's what we did there. And now we're done. Okay, so that is our solution. So we're just doing these green operations, just that simple, you know, just that simple. All right, pull it back just a smidge. Okay, let me grab a couple more problems here, and I'll be right back. Be right back.
Yes, but like holding is a type of pulling, which is a type of pushing, which is a force. What force is holding these things kind of like, because this word is super, super important here, right? Equilibrium. What does that mean about this system? Ooh, no, not necessarily the start, because it says they're touched and then attain the equilibrium state, right? So so this is a sort of after some time it reaches this state, right? If I let a ball, if I drop a ball and I catch it like a split second after dropping and it's in the air, is it fair to say that that thing's in its equilibrium state? So equilibrium, you mean you know kind of means things are equals in some way, right? Like things are balanced, but what is balanced? What is equal? What does it mean to be in equilibrium in terms of forces? Okay. I would be with you if we hadn't talked about this subtle little thing about moving but not changing my motion, right? So, what do I mean by that? Why am I being picky here? It's because this comes from F net equals MA. And so it's not about movement. There's no V in this equation, right? Because if I could throw a ball up in the air and I catch it right at the moment that it's at the top, It's not moving there. But it's not at equilibrium because the way I can prove that is a split second later, it's been moved to a new spot by the forces that are there, right? What's moving a ball when it's moving up and then coming back down? What's the thing that's not at equilibrium? What's the force that's there that's not balanced? Gravity. So to be at equilibrium means not moving, but that the acceleration is zero, which means F net is zero. Okay? So that's going to be the foundation, and the word equilibrium means that. Like when you reach a state of equilibrium, it means that all the forces are causing you to sort of like not really be able to move anywhere, because as soon as one pulls you one way, the other one pulls you up equal and opposite way, right? You know, an easy explanation of this, or something example of this is a tug of war scenario where they're not moving. Both sides are putting a lot of force in, but they're not moving. Why are they not moving? Why are they in equilibrium? Because they're equal, right? So it doesn't mean there's no forces. It doesn't mean they're not moving, right? That's a subtle one. That's a subtle one. Maybe like 2 years ago, I would have given you that without even mentioning it, right? But now we have to be careful because V equals zero doesn't mean that A is equal to zero. Like those two things are different, right? Just like my position being at zero doesn't say anything about my speed. Just because I cross the zero spot doesn't mean I'm not running really fast and will soon be past it, right? It's kind of the same relationship with velocity and acceleration. Just because my velocity is at this spot in this 1 second doesn't mean it's not going to be something else later, right? When the ball starts to move down again. Okay, so all of that to say, we can now do F net equals zero free body diagrams on these things. So they you're sort of told that they each have the same amount of charge, right? So did you sort of like choose a value there? Yeah. Yeah. Like, did you pick a particular value, or did you just sort of like keep it as Q, or have you like attempted this one yet? Okay. Okay. So now that we have that little bit of information, right, which was almost directly given to us from the question, equilibrium means F net equals zero. So there's a reasonable kind of like crumb for us to follow. Yeah? Okay, so I want to leave you to it. Like, I want to start to build some independence in our time together, right? Where we can kind of check in a little bit, but not necessarily like you can start to do these on your own, right? And kind of confirm with me because part of what we have to build together is that confidence because you do know a lot of this stuff, right? And not knowing where to attempt it is the first step of every problem. That's should like that's a hard feeling, but it's gonna happen almost every problem from now on, right? You're in the tough world of physics. So I'm gonna start to build, slowly kind of try to catch up to you. I'll build my free body diagram and hopefully we'll sort of like, if you are struggling, you can kind of check in with what my procedure is as well. Okay? Do you have your free body diagram for one yet? Okay. How many forces do you have on it? Nice. Okay, which ones are they? Yep. Yeah. Good. Um, yeah, I mean, anytime we have a two-dimensional force, you cannot do a two-dimensional FNet. You have to do FNet and FNet Y, right? So anytime I see a free body diagram with slanted or diagonal lines, not just up, down, left, rights, I have to break them down. Is that an attractive force or a repulsive force? What's your proof? But the distance arrows, like you've seen this before, where I just say like, this person is at this height, right? And I do this, the two arrows. You've seen that before, right? So that's all that is. Better proof. They tell you that it's at equilibrium, right? Can this system that I've drawn here be at equilibrium? Remember, what does equilibrium mean? It means when they're all balanced. And remember, as a physicist, your ability to evaluate vectors is only in the x and only in the y, which is only up, down, left, right. So are there ups and are there downs? Are there ups and are there downs? So that means that it's possible for ups to cancel downs, right? Are there lefts and are there rights? Not the way I've drawn it, right? They're both going to the right, the two vectors that are horizontal, right? The way I've drawn it here. You see it? Oh, wait, can you not see my screen? Oh, no. Okay, wait, one sec here. Oh, okay. Here. See that? Okay. So do you see this? Was that new? Okay, sorry. Okay, so this is, how I drew it, right? I was asking, is that an attractive force? If it was an attractive force, it would be that way, right? And we were talking about ups canceling downs. There are ups, there are downs, so they can cancel. Are there lefts and are there rights in this diagram? Oh, there's only rights, right? So there's no way that this thing can be in equilibrium, right? So that's one of those zoom out things that you can do, right? No matter what's happening in the problem, you can look at any free body diagram and say whether it could be in equilibrium. You don't know the size of anything. But if it's only rights and only downs, zero chance of it being in equilibrium. That thing has to move down and right, right? Okay, so that's also how you can sort of answer this question. The other thing is that they're moving away from each other, right? So they wouldn't want to move away from each other if it wasn't repulsion. So I'm going to use FQ. Is that okay? Or do you use FE? Okay, I'll use, okay, no problem. So I'll use FQ. Okay. I guess it looks a little bit like the G, but okay. So that's the left ball, right? Are you comfortable saying that the right ball is going to be kind of like the mirror image of this? Yeah, I think actually I can do that. I can